Welcome to TechTalk channel. In this video, we'll take a closer look at the construction process from start to finish. A must-know guide for anyone involved in building projects. You'll discover the 10 key stages that bring a construction project to life, explained in clear and professional English. Whether you're a student, a professional, or simply curious, this overview will help you understand how each step fits into the bigger picture of construction. Step 1. Building permits. Before construction begins, securing building permits is crucial. Building permits ensure that your project complies with local regulations and building codes, which vary by country. Generally, you'll need to submit a set of architectural drawings, including plans, sections, elevations, and site plans. In addition, detailed drawings from structural, mechanical, electrical, and plumbing engineers are often required. These documents must be submitted to the local government for approval. Step 2. Mobilization. Mobilization is the initial phase of a construction project, involving the setup and preparation of the construction site before the main works begin. This stage includes several critical tasks such as 1. Installation of temporary facilities. This includes the construction of temporary structures, such as building site offices, installation of temporary water and power supply systems, setting up material storage areas and equipment yards, site security and safety, setup, installing boundary fencing to secure the perimeter, ensure site safety, and control access to authorized personnel only, site clearing and access preparation, clearing and leveling the ground to enable vehicle and equipment access and to create a safe and functional working environment. Logistics and site organization. Planning site logistics, including internal roads, designated storage zones, and delivery coordination to support an efficient workflow throughout the project. Importance of mobilization. Effective mobilization is essential as it sets the foundation for the entire construction process, ensuring safety, efficiency, and schedule compliance. Step 3. Site preparation. Site preparation involves accurately setting out the building footprint relative to site boundaries. Typically, the architect oversees this to ensure precise positioning. This stage includes several critical tasks such as marking out the building on site, setting out project dimensions from the boundary, defining the building's perimeter, typically carried out by the architect to ensure correct building positioning. Site logistic, erosion, and sedimentation control plan, developing a plan to manage construction activities and protect the environment. Measures include watering down vehicles to minimize dust, saving topsoil for landscaping, protecting existing trees. Demolition of existing structures, completing any necessary demolition work. Soil investigation and subbase preparation, conducting soil investigation, placing the subbase layer, also called hardcore, to ensure foundation stability and durability. Step 4. Substructure work. Substructure works involve all construction activities below ground level. This stage typically starts with blinding, a thin concrete layer poured over the compacted subbase to create a clean, level surface for foundation placement. This stage includes several critical tasks such as excavation, digging to require depth for foundations, ground treatment, soil improvement if necessary, blinding, placing a thin concrete layer over the subbase, foundation construction, building footings, isolated strip, raft, or pile foundations. Footings are placed under walls and columns reinforced with rebar to support the concrete. Raft foundations cover the entire building footprint. Deep foundations involve piles driven deep into the ground for tall buildings. This phase is crucial as it ensures the building's stability and load-bearing capacity. Rebar installation, placing reinforcement for foundations. Formwork installation, setting up molds for concrete. Concrete pouring, casting concrete for footings and pile caps. Tie beams, connecting foundations for structural stability. Waterproofing, applying protection against moisture if required. Backfilling, refilling excavated soil and compacting. Step 5. Superstructure. Build the frame of the structure, including columns, beams, floors, and walls. This stage includes several critical tasks such as 1. Setting out and preparation. Surveying and marking precise locations for columns, beams, and slabs according to structural drawings. Installation of temporary works such as scaffolding and formwork supports. 2. Reinforcement installation. Cutting, bending, and fixing steel reinforcement bars, rebar, in compliance with the structural design and detailing. Securing rebar to maintain correct positioning, cover, and spacing as per specifications. Conducting reinforcement inspection and approval by the site engineer before concrete placement. Formwork installation. Erecting formwork for columns, beams, and slabs ensuring structural stability and alignment. Applying release agents to formwork surfaces to facilitate removal after curing. 4. Concrete works. Mixing and transporting concrete to the site ensuring required strength and workability. Pouring concrete into formwork systematically to avoid segregation. Vibrating freshly poured concrete to remove air pockets and ensure compaction. Curing concrete for the specified duration to achieve design strength and durability. 5. Structural element construction. Construction of vertical elements, columns and shear walls according to design sequence. Construction of horizontal elements, beams and slabs including edge beams and cantilevers. Ensuring continuity and proper connection between structural elements. Step 6. Building enclosure. The building enclosure consists of the outer skin and internal components that protect the building's structure from weather conditions. This stage of construction includes installing elements such as blockwork, windows, curtain walls, glazing, doors, roof lights, and roofing systems. Proper installation of the building enclosure is crucial for the building's long-term performance and maintenance. Components of the building enclosure. Foundation and below-grade walls, the part of the structure that is below the ground. Exterior walls, the above-grade walls and the materials that form them. Roof system, the top layer of the building that protects from the elements. Openings. These are the openings for doors, windows, and other features in the exterior walls. Waterproofing and barriers. Layers designed to control water, air, and vapor movement, such as air and vapor barriers. The design and construction of the building enclosure have a major impact on a building's performance. For a building to be safe and efficient, the enclosure must be airtight. A continuous air barrier reduces unwanted airflow, which lessens energy use and prevents condensation. Watertight. A comprehensive system of water-resistant barriers and flashings channels water away from the structure. Thermally efficient. Proper insulation minimizes heat transfer, which contributes to energy savings and occupant comfort. Vapor permeable or impermeable. The enclosure must control vapor to allow the building to breathe, which prevents moisture from becoming trapped within the wall assemblies. Step 7. Mechanical, electrical, and plumbing, MEP. Systems installation. MEP systems are essential for building functionality and comfort. This phase involves installing HVAC systems, including ductwork, air handling units, and ventilation components. Setting up electrical equipment such as wiring, lighting fixtures, generators, and transformers. Installing plumbing systems, including piping, fixtures, and drainage. Coordinating MEP installations with structural elements to avoid clashes and ensure smooth integration. Scheduling and planning overlaps with superstructure and building enclosure works to maintain workflow efficiency. Testing and commissioning MEP systems to ensure proper operation and compliance with design specifications. Step 8. Interior finishes. The interior finishes phase, also known as ID work, involves the installation of architectural finishes and built-in elements that define the building's interior aesthetics and functionality. This phase involves floor finishes, tile, timber, carpet, vinyl installation, skirting and floor trims, wall finishes, painting, wallpapering, wall panels, tile, stone cladding. Ceiling, works, gypsum, suspended, timber ceilings, lighting integration and ceiling detailing, millwork and built-in furniture, wardrobes, cabinets, counters, decorative trims and hardware fitting, doors and ironmongery, door installation, timber, glass, locks, hinges, handles, architraves, fixtures and fittings, sanitary accessories, lighting, switches, loose furniture, freestanding desks, chairs, sofas, tables, final works, touch-ups, cleaning, defect rectification, inspection, commissioning, and handover. Step 9. Landscaping. Landscaping is the final stage of construction that enhances the building's external environment through functional and aesthetic outdoor design. Though often underestimated, it plays a key role in the overall visual impact and user experience. This phase involves 1. Softscape work. Softscape work refers to landscaping tasks involving living elements such as planting trees, shrubs, grass, soil preparation, installation of irrigation systems, and maintenance of plants. Hardscape works. Hardscape works include the construction of pathways, pavements, stepping stones, planters, retaining walls, edging, boundary treatments, and the installation of water features such as fountains, ponds, and streams. Site furnishing and amenities. Site furnishing and amenities include outdoor furniture such as benches and pergolas, lighting fixtures, seating areas, shade structures, and trash bins. Finishing and maintenance. Finishing and maintenance includes turfing and final planting, initial maintenance to help vegetation establish, and the final cleanup and handover of the site. Step 10. Final construction. The final construction phase completes the project by preparing the building for occupancy through final installations, inspections, and adjustments. Signage installation, tenant identification, safety signs, wayfinding, and directional signage, especially important in large complexes like hotels and malls. Final inspections, comprehensive checks of all building systems, finishes, and safety features to ensure compliance with quality and regulatory standards. Adjustments and touch-ups, correcting defects, completing minor repairs, and finalizing finishes to meet specifications. Handover preparation, organizing documentation, user manuals, and ensuring the building is fully operational and ready for client occupancy. By understanding the stages of construction, you can better appreciate the complexity and coordination involved in construction projects. In the next episode, we'll provide you with downloadable checklists for every construction phase, from excavation to finishing. The download link will be available in the next video description, so don't miss out. Don't forget to subscribe. If you found this video helpful, please like the video, subscribe to TechTalk channel, and turn on notifications to get alerts when new videos go live. Thanks for watching, and we'll see you in the next episode.